Feature scaling is incomplete without talking about standardization. So, what is standardization, and is it a better feature scaling technique than normalization? Does standardizing your dataset convert it into a normal distribution? But before we try to answer these questions, click on that subscribe button that you find below this video and also turn on the bell icon for notifications. Because I'm going to keep uploading some really exciting videos on machine learning and AI, and a series of solid educational content is coming your way, and I do not want you to miss it. So go ahead and subscribe to my channel right away. In the last video, we saw what normalization was and how it used the minimum and maximum of each of the columns to rescale the dataset. If you haven't checked it out yet, head over there right after this video. In contrast, standardization uses the mean and standard deviation of each of the columns to rescale it. Let's begin with the dataset which we have already seen. 10 rows, each representing a person with 2 columns or attributes, which are age and salary. Two parameters in the spotlight are mean and standard deviation, and let's make a note of it for each of the columns. So the mean of the age column is around 40 and the mean of the salary column is around 608,000. Similarly, the standard deviation of the age column is around 16, whereas the standard deviation of the salary column is around 325,000. Mean is nothing but the average of a set of values, whereas standard deviation describes how spread out your data points are from the mean. The goal of this technique is to rescale your dataset such that the mean becomes 0 and the standard deviation becomes 1. Let's take a look at the mathematical representation. It's quite simple. All you're doing here is taking each value and subtracting the mean from it and dividing the result by the standard deviation. Now, if there is any value equal to the mean, it will become 0. The values greater than mean will be positive and the ones less than mean will be negative. Remember, we chose to do feature scaling because different columns can have different ranges and they can be in different units. For instance, age in our dataset ranges from 15 to 68, whereas salary ranges from about 9,000 to 900,000. Speaking of units, age is in number of years, whereas salary is in dollars. The centering of the mean at 0 takes care of the varying ranges, and the division by standard deviation takes care of the varying units. What was earlier 15 years is now minus 1.6 unit standard deviation, and what was earlier $9,000 is now at minus 1.9 unit standard deviation. You see how both these columns are represented in the same unit, which is unit standard deviation? That's pretty much it. It's important to remember that although you're centering your mean at 0, standardizing your data does not bound your range of values, unlike normalization where all the values are between 0 and 1 strictly. Secondly, there is a big misconception that after standardizing your data set, it gets converted into a standard normal distribution. We all know that a standard normal distribution, which is also known as the bell curve, has a mean of 0 and a standard deviation of 1. But just because we rescaled our data set to have a mean of 0 and a standard deviation of 1, it doesn't necessarily convert it into a standard normal distribution or the bell curve. Here's a graphical representation of how our dataset looks like before and after standardization. There is absolutely no change in the way the data is distributed on the graph before and after. And it definitely hasn't got converted into a bell curve. A standard normal distribution always has a mean of 0 and a standard deviation of 1. But it isn't always true the other way around. That is, if any distribution has a mean of 0 and a standard deviation of 1, it doesn't necessarily have to be a standard normal distribution. Okay, enough of theory there. Let's jump in and start implementing this in Python using pandas and scikit-learn library. This time I'm importing the matplotlib module as well for showing you the data plots, but I won't be explaining that part of the code as it's slightly irrelevant to this video. Let's import the necessary modules. We need pandas for loading our dataset as a data frame, the standard scalar class from sklearn.preprocessing, which will standardize our dataset, the random module for creating a random dummy dataset. I'm also importing pyplot from matplotlib and setting up a scalar plot method for graphically representing the data and the results. You can ignore this function for now, but this is just a helper function to create our random dummy dataset. On creation, our dataset looks like this, which you have already seen. Here's the scatter plot of our dataset where we have age in the x-axis and salary in the y-axis. Now, we must instantiate the standard scalar which we imported from the sklearn.preprocessing module and call the fit method. This returns the scalar object but internally figures out the mean and variance of the dataset for each of the columns. Next, we call the transform method on the scalar object by passing the data frame as an argument, which returns a standardized NumPy array which needs to be converted back to a data frame. Now you just call pd.dataframe with a scaled NumPy array and the columns of the original data as the arguments, and your resultant data frame looks like this. The code will be shared as Jupyter Notebook, whose GitHub link is in the description below. Do check it out and play with it. I would like to conclude this topic with a very important question, which is which one to go for, normalization or standardization? Well, the answer to that is it depends. If your data is more similar to a normal distribution, you could standardize your data but otherwise prefer normalization. It also largely depends on the dataset you're working with and the algorithms you're using. Hence, trial and error alone can reveal which one is best suited for your own use case. So that concludes this video on standardization. Thanks for watching. Do give it a like and subscribe to my channel.